Alright, so hopefully you did really well in the last 3 practice problems. We're going to go through and just make sure we go over them. That way, if you got anything incorrect, we can find out why. So again, these are all the ones where it's totally jumbled up, and there's no easy fix here. We're trying to look for what's a simple target to isolate because neither equation has a variable alone. The one that I'm seeing as I look through is that this y is almost alone, so we're going to try and isolate for y, which means we need the x to go to the other side. Since x is positive, we would minus it from both sides. And now we have the equivalent equation of y equals 18 minus 2x. We would use that expression to plug in where y is in the opposite equation. So we've got 6x plus 3 times y equals 54. We just found out by rearranging this one that y is equal to 18 minus 2x. When we distribute that 3, we find out that 3 times 18, don't have a calculator, so I'm going to have to do that in my head real quick. 3 times 8 is 24. 3 times 1, so 54. And then 3 times negative 2 is going to give us a minus 6x, and that all equals 54. So when we start combining like terms here, we've got 6x minus 6x. Well, those are going to cancel. And when I bring down what's left, I've got 54 equals 54. So previously I talked to you about this. If all the variables go away, and all I have left is a number equals another number, I need to decide if it's true or false. So is 54 equal to 54? Yes, it is. So it's a true statement, which means it is infinite solutions. Again, if it's infinite solutions, that means on the graph, when one line is graphed, the other line comes out to be the same thing on top of itself. So if I were to rearrange these and put them into y equals form, they would all reduce to the same answers. Even now, I can see that this 6, this 3, and this 54, if I were to divide them all by 3, it would actually give me the other equation. Because 6 divided by 3 is 2, 3 divided by 3 is 1, and 54 divided by 3 is 18. These are the same equation. This is just a larger version of the other one. It's just all been multiplied by 3. So they're the same equation, which is why it came out to be infinite solutions. Number 10, you needed to decide what to isolate. This guy here, this x, would have been what I would have chosen. He looks like an easy target. He's almost alone. He's got a 1 coefficient. So to do that, we need to move this minus 3y to the other side. So we would do the opposite and add 3y to both sides. And we have our new equation that x is equal to negative 2 plus 3y. We'll use whatever x is equal to now, plug it into the opposite equation where x is. And so we've got 10 times x plus 8y equals negative 20. We found out that x is equal to negative 2 plus 3y. Distribute our 10. And so that's going to give us negative 20 plus 30y plus 8y equals negative 20. So first we need to combine like terms. I've got 30 plus 8y, so I've got negative 20 plus 38y equals negative 20. When I try to move this minus 20 to the other side, I would have to add it to both sides, and they both end up giving me 0. So commonly when this happens to you guys, you kind of freak out, and you're like, oh no, something went away, it's no solutions. No, I gotta keep working. I still have a y involved. Negative 20 plus 20 is 0. So I've got 38y equals 0, and I still have a problem to finish. I'm going to divide both sides by 38. And 0 over anything is just 0, so our y coordinate is equal to 0. We still got to take that guy, put it back into one of the originals or our new one that is equivalent to find out what x is equal to. Since this is already set up to just plug in and tell me what x is equal to, I'm going to use this one. And so I've got x is equal to -2 plus 3 times y. We just found out y was 0, so x is equal to -2 plus 3 times 0 is 0, so x is just equal to -2. So again, I got to make sure I put my x coordinate first. The point where these two lines intersect is at the point -2, 0. Last one we're supposed to try. 3x minus y equals -8. 5x plus 2y equals 5. The easy target I see this time is this y. So I'm going to try and move the 3x away from it. To do that, since 3x is positive, I'm going to minus 3x from both sides. Got to be careful here though, because there's a minus in front of that y, so I got -y equals -8 minus 3x. And you already know I cannot have a negative variable in my final rearranged example. So there's an understood -1 there. I need to divide everything by it. When I do that, I'm going to get that y is equal to now a -8 divided by -1 is a +8. A -3 divided by -1 is a +3x. So now I actually have what y is equal to, and I can take this expression, plug it in where y is. So we've got 5x plus 2 times y equals 5. When we did it all the way, cleaned it up, we found out y is equal to 8 plus 3x. Distribute the 2. We've got 5x plus 2 times 8 is 16. 2 times 3x is 6x. And it's all equal to 5. Combine our like terms on this left side. And we have 5x plus 6x is 11x plus 16 equals 5. Then I need to move the 16 over by subtracting from both sides. And 11x equals 5 minus 16 leaves us with a -11. Divide both sides by 11. And x is equal to -1. So that's our x variable. Got to go back and find our y variable. I can plug it into this one, I can plug it into this one, but I'm going to be smart and plug it into this one because it's just going to be the easier way to go. So y equals 8 plus 3 times -1. So y equals 8 minus 3. So y equals 5. So if that's the x, this is the y. Got to make sure I write the x coordinate first. So the point where they're going to intersect is the point -1, 5. Alright, so to recap, you always need at least one of the equations to have either x alone or y alone. When it's already done, you will take that expression and plug it into the opposite equation in place of that variable and actually solve out for the opposite variable. Once you get the value of that variable, you need to plug that actual number back into one of the original equations or your new one and solve for the opposite variable. If neither one of them are isolated for a variable at first, you have to be able to rearrange. And like I said, you can choose x or y in either equation to isolate, but you're going to want to be strategic about it. You're going to look for the easy targets here, the ones with one coefficients. Those are usually the easiest. Sometimes it gets so hard, none of them have one, but that's really not going to be on our level. That's more of an algebra kind of high school next year level. This is probably about as difficult as it's going to get in here.